Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter symbols and formulae. In this session we are going to see about valency and atomicity of the elements. What is meant by valency and what is atomicity we are going to see in this session. First let us go through the valency. During the formation of molecules of compounds, atoms combine in certain fixed proportions, isn't it? For example, if you see formation of molecule like water. In the formation of water, we know hydrogen and oxygen atoms, they combine in certain fixed proportion, isn't it? In the same way, in the formation of all kinds of compounds, atoms always combine in the fixed proportions. This is because of the fact that atoms have different combining capacities. Okay, if you say the water itself again, however it is prepared, always hydrogen and oxygen atoms they combine in the fixed proportion. Okay, this is just because of the each and every atoms they have certain combining capacities. Different elements they have different combining capacities. This combining capacity of the elements is known as their valency. Okay, the combining capacity of elements is called its valency. Valency is measured in terms of hydrogen atoms or oxygen atoms. So the combining capacities of the different elements are compared in terms of hydrogen atoms or sometimes with the oxygen atoms also. The valency of hydrogen is taken as 1 and it is selected as a standard of valency. So by taking the valency of hydrogen as a standard, the valencies of the remaining elements are measured. Okay, the valency of different elements are measured in terms of either hydrogen or oxygen. So while calculating in terms of hydrogen, the valency of hydrogen 1 it is taken as a standard and the valencies of the remaining elements are measured based upon this standard value. Thus the valency of an element also can be defined as the number of hydrogen atoms which combine with an atom of it. Okay, if you say the valency in terms of hydrogen, it also can be defined as the number of hydrogen atoms which combine with an atom of it is taken as its valency. Let us see an example so that we can understand. In methane molecule, if methane means it is one of the chemical substance with the molecular formula CH4, means one carbon atom combined with four hydrogen atoms. So we can say in methane molecule, one atom of carbon combines with four atoms of hydrogen. So what we defined here, valency in terms of hydrogen, what we said, the number of hydrogen atoms which combine with one atom of that element is taken as its valency. If we see with one atom of carbon, four hydrogen atoms are combined here in the formation of methane molecule. Now we can say the valency of this atom which is combined with hydrogens is taken as 4. What is the atom called? Carbon. So now the valency of carbon is considered as 4. Did you understand? So in terms of hydrogen, it is considered as the valency is defined as the number of hydrogen atoms that are combining with one atom of that element is taken as its valency. So here in the formation of methane molecule, one atom of carbon combining with four atoms of hydrogen. So the combining capacity of carbon is said to be 4. Combining capacity is nothing but valency. So the valency of carbon in this compound is 4. Okay. Since all the atoms do not combine with hydrogen, so the valency of elements is also defined in terms of other elements like oxygen and chlorine also. Okay. So in this way, as we have seen in the methane molecule, the valency we got it as 4. But most of the elements they may not react with the hydrogen. All the elements not expected to be reacting with the hydrogen. That's why Some elements, for some other elements, valency is expressed or compared in terms of oxygen. Or some other elements, the valency is defined in terms of chlorine. Now let us see how the valency is defined in terms of oxygen. Valency in terms of oxygen. Since the valency of oxygen is 2, because if you see in the water molecule formation, one oxygen atom is combined with two hydrogen atoms. Just now we have seen the valency definition in terms of hydrogen. The number of hydrogen atoms that are combining with one atom of an element is considered as its valency. Now here two hydrogen atoms are combining with one atom of oxygen. So the valency of oxygen can be taken now as 2. So it is taken as a fixed now, or it is taken as a standard. By taking it as standard, the valencies of other elements are measured in terms of oxygen. So in terms of oxygen, the valency can be defined as double the number of oxygen atoms with which one atom of an element can combine is called its valency. Suppose an element is combining with X oxygen atoms, then its valence will be 2x. So it is defined as double the number of oxygen atoms with which one atom of an element can combine is called its valency. Let us see an example for this also. For suppose in calcium oxide molecule, one atom of calcium is combining with one atom of oxygen, isn't it? Now, double the number of oxygen atoms that are combining with one atom of calcium is taken as valency of calcium. So, one atom of oxygen is combining, if you multiply it or double it, it becomes 2. So, the valency of calcium is considered as 2. Okay, in this way, double the number of oxygen atoms which are with which one atom of an element is combining is called its valency. So here calcium atom is combining with one atom of oxygen. If you double it, it becomes 2. So the valency of calcium is considered as 2. Okay. See here, the valency of certain elements are mentioned. This is sodium, magnesium. Sodium valency is 1. Generally, for metals we can say based upon the number of electrons in their last shell, their valency can be told. If we see sodium, its atomic number is 11 and it will be having electronic configuration 2, 8, 1. So it is having only one electron in its last shell. So its combining capacity is 1. Okay. So in this way, for different elements, their combining capacities or valencies are mentioned here, which we use frequently. Sodium, potassium, fluorine, chlorine, hydrogen, nitrogen, calcium. Observe once these. Okay, some elements they're having single valence means they are called monovalent elements. Mono representing one. Monovalent means elements with a single one valency. So the sodium, potassium, fluorine, chlorine, hydrogen, these are called monovalent elements. Whereas if you see magnesium, calcium, these are having valency 2. If valency is 2, then what can be called there? Bivalent. By representing here 2. Two valence elements. So bivalent elements. Next, if we observe magnesium and nitrogen, these are having valency 3. So they are called trivalent elements. Okay. Next, concept of variable valency. Yes, when an element exhibits more than one valency, it is said to be variable valency. It is said to be exhibiting variable valency. That element is called variable valent element. Yes, generally elements they will exhibit certain combining capacity or valency. But certain elements they can exhibit more than one valency. Certain element, those elements which can exhibit more than one valency are called variable valent elements, and that phenomenon is called variable valency. Okay. The reason for the variable valency in certain metals is that depending upon the experimental conditions, an atom of the metal loses one or more electrons that are present in its outermost shell, nothing but valence shell. And sometimes it also may lose some electrons from the shell next to outermost shell. That is why sometimes it will show one valency and some other times it may show another valency. Okay, that's called variable valency. So did you understand the reason? So in some of the metals, they lose in some chemical reactions their electrons from the outermost shell. Outermost shell means last shell. Suppose we consider this is an atom with the different shells. So that may have so many number of electrons in all the shells. So some atoms in certain kind of chemical reactions they lose electrons only from the outer shells. Then they show certain valency. In some other chemical reactions, along with the electrons from the outermost shell, they also release certain electrons from the last but one shell that is called next to outermost shell. Then one more kind of valency to exhibits. In that way, these elements can show more than one valency based upon the experimental conditions. So these elements are called variable valent elements. Okay. Thus, they exhibit variable valency. Then we may get one doubt. If an element is exhibiting one valency, then it is given a fixed name. Suppose if you see sodium, sodium exhibits a plus one valency, then it is called sodium ion. If you say oxygen, it will gains two electrons, so its combining capacity is two. So we can say its ion value name is oxide ion. But if you say some element they're exhibiting more than one valency, then how to name these ions with different valencies? That is, let us see here how to name these different ions which are formed with different valencies by an element. If an element exhibits two different valencies, then suffix ous is attached at the end of the name of the metal for lower valency, and suffix ic is attached at the end of the name of the metal for higher valency. So if an element is exhibiting two different valencies, then the ion with lower valency is named by attaching ous us at the end of its name, and the ion with the higher valency is named by attaching ic at the end of its name. Okay, in this way they are named. Let us do an example here. For example, iron can exhibit two valencies, plus 2 and plus 3. Okay, see here, iron combined with two chlorine atoms here. Each chlorine atom valency is 1, so iron valency becomes here 2. And here, three chlorine atoms are combining with iron. So, iron valency in this compound is 3. Now, in this way, the same iron exhibiting two different valencies. Now, how to name these two different ions? That's the way here we are going to see. So here the charge or a valency of iron is 2. Then it is ion with the lower valency you can say. It is named with OUS us attaching at its name. Actually the name of iron in the Latin is ferrum, isn't it? Ferrum. By removing the last one or two letters from its name, OUS us is attached at the name. It becomes now ferrous. It is called now ferrous ion. Fe plus 2 is called ferrous ion. And it is a higher valency ion. Fe plus 3 in this molecule is ion with the higher valency. It can be named by removing these two letters from its original name by attaching IC It becomes now ferric. So Fe plus 3 ion is called ferric ion. Fe plus 2 ion is called ferrous ion. In this way, the two ions formed by an element can be named by attaching us and ik at their end of their names. Okay, this is about variable valency. Let us see here different elements other than iron which are exhibiting variable valencies. Iron we have seen just now. Fe plus 2 ferrous ion. Fe plus 3 ferric ion. In the same way, copper also can show two different valencies, Cu plus and Cu plus 2. Here, Cu plus ion is called as cuprous ion because the name of copper in the Latin is we know as cuprum. By removing one or two letters from its name at the end, OUS us is attached to this. It becomes no cuprous for the lower ion. And in the place of this IC is attached, it becomes then cupric. In the same way, argentum, argentus and argentic. Mercury, mercurous, mercury. Okay, this is about variable valencies of different elements. Now, let us see the another concept, atomicity. The molecules of an element are constituted by some types of atoms. Molecules of many elements such as argon, helium, etc. are made up of only one atom of that element, isn't it? Because we know these elements are least reactive elements. They do not combine with any other elements, and even they won't combine even themselves also. They will be existing always in the individual atoms form. So in their molecules there will be only one atom. But this is not the same case with most of the elements. So most of the non-metals especially, they won't exist in a single atomic form. This is the case only with noble gases, and most of the metals. They exist with the single atoms in their molecules. But most of the non-metals, they won't exist as this. For example, a molecule of oxygen consists of two atoms of oxygen, and hence it is known as a diatomic molecule, because we know the molecular formula of oxygen is O2. So in the molecule of oxygen, there are two oxygen atoms combined chemically. How many atoms are there? Two atoms in one molecule. That's why oxygen is said to be diatomic molecule. If three atoms of oxygen unite into a molecule instead of two atoms as usual, then it will form a molecule with the formula O3. This is called ozone. So here ozone constitute three atoms of same element oxygen. So as there are three atoms in the same molecule, it can be called triatomic molecule. So in this way, the number of atoms in the molecules of the elements differ from one element to another element. Now we can define this here as the number of atoms constituting a molecule is known as its atomicity. The number of atoms present in one molecule of an element is called its atomicity. Okay. Molecules of metals and some other elements such as carbon do not have a simple structure but consists of very large and indefinite number of atoms bonded together. They only have single atoms. They will be having so many number of atoms combined together in the indefinite number. But generally for non-metals we can say this. Generally elements exist as single atoms. However, sometimes two or more atoms of an element combine with one another to form compound atom, which is also called molecule. Based upon this, depending upon the number of atoms present in its molecule, the elements can be classified into different types. That means, based upon the atomicity, elements can be classified into different types. What does it mean by atomicity? The number of atoms present in one molecule of an element is called atomicity. Based upon the atomicity, elements can be classified into different types. Let us see those here. Monoatomic elements. First classification you can say as monoatomic elements. Here mono represents single or one. That means the molecules of elements which contain only one atom in them are considered as monoatomic elements. The molecules of monoatomic elements contain only one atom in them. Let us see some examples for those. For example, metals like copper, silver, and some other elements like noble gases, neon, helium, argon, krypton. These all they won't exist in the group. In their molecules, they contain only one atom. So these all are considered as monoatomic elements. Next, diatomic elements. The molecules of diatomic elements contain two atoms. So we can define these as the elements in which the molecules contain two atoms are called as diatomic elements. For example, hydrogen, oxygen, nitrogen, chlorine, etc. If you observe these molecules, each molecule contains two atoms of that element. That's why these are called diatomic elements. So here di represents two. Okay, diatomic means elements the two atoms in their molecule. Not only one or two atoms in the molecule. Some other element they may containing more than two atoms also. They are called polyatomic elements. The molecule of a polyatomic element contains more than two atoms. The elements in which molecules contain more than two atoms combined together are called as polyatomic elements. For example, if you see ozone, in ozone there are three atoms of oxygen combined together. Now we can say ozone is a triatomic element. Okay. If you see phosphorus, it contains four atoms of phosphorus combined together. Now we can say phosphorus is a tetraatomic element. If we consider sulfur, in sulfur molecule there are eight atoms of sulfur combined together. So we can say sulfur as octaatomic, and abnormally great number of atoms present in the molecules of carbon. It is one of the example for carbon molecules. We call this as actually fullerenes. We are going to learn in the higher classes. Now here, in the molecules of this carbon, there are around 60 to 120 atoms of carbon. So these are all together considered as polyatomic elements. The elements in which the molecules contain more than two atoms combined together are called polyatomic elements. Okay. Let us see some more information about the elements. We know till now scientists they have discovered so far 118 elements. Out of these 118 elements, 104 elements occur as solids and 11 elements exist as gases, and two elements are existing in the liquid state. We know only two elements out of 118 elements, only two are existing in the liquid state. One is a metal and another one is non-metal. What is a metal in the liquid state? Yes, it is mercury. Mercury is a liquid metal, whereas one more element that is bromine. Bromine is a liquid non-metal. Out of these 118 elements, 93 elements occur as metals and 11 elements exist as non-metals, and 6 elements occur as noble gases, and even 7 elements occur as metalloids. What does it mean by metalloids? We know about metals and non-metals, but there are certain elements which can exhibit the properties of both metals and non-metals. They are called metalloids. Okay, this is some more information about elements. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates on recorded videos.